Hello, this is a continuation video for the formulas of a Laplace transform. So in the previous lecture, we have defined what is meant by Laplace transform, and then I've started with important formulas which we will require in a Laplace transform. So first formula was L of 1 is equals to 1 upon f. L of e raised to at is equals to 1 upon s minus a, where s is greater than a, and L of t of n is equals to n factorial upon s of n plus 1. So these three formulas we have covered it in our previous lecture. So we have completed our proof like this. So L of 1 is equals to 1 upon s. We have proved L of e raised to at is equals to 1 upon s minus a, and then L of tn is equals to n factorial upon s of n plus 1. So now in this video we are going to learn the remaining four formulas which are almost same, just a minute difference, but they are a bit confusing to remember. So see, now first one is L of cos h at, which is equals to s divided by s square minus a square. Similarly, sin h at will be a divided by, denominator comes out to be same, a divided by s square minus a square. Similarly, L of sin at is equals to a divided by s square plus a square, where a square is greater than a square, and L of cos at is equals to s upon a square plus a square, where s is greater than 0. So in these four formulas, the common thing is that for sine term, for cos term, s will be there at numerator, okay, and for sine term, a term will be there at the numerator. And with hat for both, it will be a square minus a square, and for only at, it will be a square plus a square. So bit easy also and bit confusing also. Okay, so now I'll start with proof 4. So my fourth proof says that L of cos h of at is equals to s upon s square minus a square. So here we are going to use a formula of cos h at, which is it's just a cos theta formula. Cos theta is equals to e theta plus e raised to minus theta upon 2. So that formula we are using it here. So we'll start with this. So L of cos h at is equals to L of e raised to at plus e raised to minus at upon 2. So this is a formula which is equals to 1 upon 2 L of e at plus L of L 1 upon 2 e raised to minus at. So we have separated the L. Now what we have done is we have substituted one formula here. What formula is this? So this is equals to 1 upon 2 1 upon s minus a plus 1 upon s plus a. Which formula we have used? We have used L of e raised to at, which is equals to 1 upon s minus a. That is our formula number 2. We have used here. We have substituted here. So we are getting these two results. So as a result, what we are getting it here, it is equals to 1 upon 2 s plus 1 plus s minus a, which is equals to s square minus a square, or in general a get cancels out, so s divided by s square minus a square. So hence proved with this. Similarly, we will be solving for the sine h of at, which is equals to a upon s square minus a square. L of h of at, which is equals to L of 1 upon 2 e raised to at minus e raised to minus at. So next step it comes out to be, it will be 1 upon 2 L of e of at minus L of e raised to minus at. So this term we are getting it as 1 upon 2 1 upon s minus a minus 1 upon s plus a. So which is equals to s plus a minus s plus a divided by s square minus a square. So s's get cancelled, so we are getting 2 get cancelled, so we are getting a upon a square minus a square. Similarly, sine at is equals to a upon a square plus a square plus a square. So which is equals to L of sine at is equals to L of e raised to iat minus e raised to minus iat divided by 2i. So which is equals to 1 upon 2i comes out to be common. L of e raised to iat minus e raised to minus iat. So 1 upon 2i L of e raised to iat minus L of e raised to minus iat. So this we are substituting it as 1 upon 2i 1 upon s minus ia minus 1 upon s plus ia. So solving this further, s plus ia minus s minus s minus of minus it becomes plus, that is plus ia. So s's get cancels out in the next step. So we are getting it as 2ia 2i upon s square plus a square. So 2i gets cancelled, it comes out to be a upon s square plus a square. So hence what we have to prove is that L of sine at is equals to a divided by s square plus a square plus a square. So seventh and the last proof is L of cos at is equals to s upon s square plus a square. So L of cos at is equals to L of e raised to iat plus e raised to minus iat upon 2. So as we are having this formula, that is cos theta is equals to e theta plus e raised to minus theta upon 2. So substituting that, we have got that part. So which is equals to 1 upon 2 L of e raised to iat plus e raised to minus iat. So opening the brackets, 1 upon 2 L of e raised to iat plus L of e raised to minus iat. So solving this, we are getting 1 upon s minus a plus 1 upon s plus a. So solving this steps, 1 plus ia plus s minus ia. So s minus I get cancelled. S square plus a square, which is equals to s divided by s square plus a square. So as a result, we have solved all these seven formulas, the important formulas for the Laplace transform. So that's it for this video. Thanks for watching.